Hello viewers, welcome to this session. This is lecture 2 of the course Mechanics. I am Dr. Rajesh Kumar Thakur from Bhopal School of Social Sciences, Bhopal. The various subtopics of today's discussions will be resolution of vector, vector multiplication, scalar or dot product, various properties of dot product, and that will be followed by certain exercises. Let us start with the topic resolution of vector. See, by vector we mean the vector quantity. And the resolution of a vector is a process of splitting up of a vector into its two or more components. For example, here in the diagram, we are having a vector r that is placed somewhere there, that is acting somewhere there in the xy plane as shown in the figure. The vector r is making an angle theta with the x-axis. This vector r is a two-dimensional vector and we can resolve it into its two component. One component that will be along x-axis, that is known as what? Horizontal component, and that will be equivalent to r cos of theta. Another component that is what? Vertical component of this vector, that is equivalent to y and is equals to r sine of theta. So these are two orthogonal component vectors of this vector r which is acting in xy plane. Now let's start with the topic, that is multiplication of vector. There are three types of multiplication of a vector. A vector quantity or a vector can be multiplied by a scalar, that is first category. Number two is a dot product or scalar product. Number three is a vector product or cross product. The first one is multiplication of a vector by a scalar. In this type of multiplication, we have a scalar. When this scalar is multiplied to any vector, it results into a new vector with different magnitude without any change in its directions. For example, we have a vector A that is a three-dimensional vector and that can be written like 2i plus j minus k cap, plus k cap, and suppose it is to be multiplied by any scalar number, let us say 5, then the new vector, let's call it B vector, will be simply equal to 5 times of this vector, that is 2i plus j plus k, and the resultant vector we can have is 10i plus 5j plus 5k. So this is what? Multiplication of a vector with a scalar quantity. Now let us start with a very important kind of multiplication of vector, that is a scalar product or dot product. Suppose we are given with the two vectors a and b and we have to find out their scalar product, then it can be written like the scalar product of two vectors a and b is equal to the product of their magnitudes and cosine of the angle in between them. Here in the figure, we are having two vectors, vector A and vector B, which are forming angle theta in between them. Here we are having the component vector of B along the direction of A vector, that is what? B cos theta. You can also call it horizontal component of vector B that lies along the direction of vector A. Mathematically, A dot B, that is equal to AB cos of theta. Here we can note one thing, that the scalar product or dot product in between any two vector quantity is all, or it results into a new quantity which will always be a scalar quantity. That is what? Dot product of two vectors is always a scalar quantity. Here we are having in this expression, we are having this A and B, they are representing the magnitude of the two vectors A and B, and theta is what? The angle of their inclination. Now let us discuss some properties of scalar product or dot product. The very first property is what? The condition for two vectors to be perpendicular. If we have to find out the dot product of two vectors which lies exactly perpendicular to each other, I mean to say they are forming 90-degree angle with their directions, that is theta in this case will be 90 degree, then from the expression of the dot product, that is what? A dot B is equal to AB cos of the angle. Here angle is 90 and we all knows that cos 90 degree that equals to 0 and therefore the dot product will be equal to 0. Therefore, we can conclude that the dot product of two vectors which lies exactly perpendicular to each other, that is always equal to 0. See, in terms of orthogonal unit vector, we all know that in our coordinate system, we used to take 3 directions, that is what x, y and z. So, along x-axis, we used to have unit vector I cap, along y-axis we have the unit vector j cap, and along z direction we have a unit vector k cap. These are the unit vectors which acts exactly perpendicular to each other. So, if we have to find out the dot product in between them, suppose we have to find out the dot product in between a unit vector I cap and j cap, which are exactly perpendicular to each other, then it will be equal to 0. Similarly, j dot k and k dot I, as they are forming an angle of 90 degree with each other, so their dot product will also be equal to 0. One thing we can add here also, that that is what dot product obeys commutative law. It doesn't matter what you are finding out, whether it is I dot j or j dot I. Both the dot products are equal. So, as the I dot j equals to 0, similarly j dot I will also be equal to 0. And similarly k dot j will also be equal to 0. And similarly I dot k will also be equal to 0. So, this is what the very first property, that is what condition of two vectors to be perpendicular. Next one is the condition for two collinear vectors. The two vectors, they are said to be collinear if they are acting along a line. Now, here also there are two cases. If they are acting along a line, they might be acting along the same direction like this, means they are forming an angle of 0 degree with each other, or they might be acting just opposite to each other like this. It means they are forming an angle of 180 degree along 180 degree with their directions. Here we have taken both the cases. For theta equal to 0 degree, as cos 0 that equals to 1. Therefore, a dot b is equals to a into b. Means in case we are having two vectors which are acting along the same directions, then their dot product is simply equal to the product of their magnitudes. In another case, when theta is 180 degree or pi, then cos 180 degree that we know is equal to -1, and therefore their dot product will be equal to negative of the product of their magnitudes. The next property of the scalar product is the scalar product of two equal vectors. The scalar product of two equal vectors is equal to the square of its magnitude. In case we are having a vector A and its dot product is obtained with itself only, then it is equal to A square of its magnitude. In the same way, suppose we have to find out the dot product in between the two similar unit vector. Suppose we have to find out the dot product in between I and I cap, in between j cap and j cap, in between k cap and k cap. Since they are forming an angle of 0 degree with each other, as they are equal vector, if I cap is acting along x-axis, it is quite obvious that I cap another I cap that will also be acting along x-axis, and that is the reason they will be forming an angle of 0 degree with each other. And we all know that cos 0 that equals to 1, and therefore I dot I that is equals to 1. Because if we want to operate it in the mathematical expression of dot product, then first of all what we have to take is the magnitude of first unit vector, then magnitude of second unit vector, and then cos of angle in between them, and that will be equal to 0. So it will give 1, and 1 into 1 is also 1. Therefore, it is 1 here. The another two properties of dot products are dot product obeys commutative law, as I have also mentioned earlier, that A dot B is equals to B dot A. There will be no change. By changing the order, the dot product will not alter. Another one is the dot product that obeys distributive law. Distributive law is like A dot B plus C, that is equals to A dot B plus A dot C. Here in this slide, we have calculated the dot product of two three-dimensional vector. One is vector A, which is taken AXI plus AYJ plus AZK, where AX, AY and AZ are its component vectors along the three axes, x-axis, y-axis and z-axis. Similarly, we have another vector B, which is having its three components, that is BX, BY and BZ along the three axes, that is x-axis, y-axis and z-axis. Then the dot product in between these two, that can be written like this, A vector dot B vector, like this. Now, from the earlier discussion, we have certain conclusions that I dot I, that is equals to 1. And similarly, I dot j or j dot k or k dot I, that equals to 0. So, whenever this dot product is operated and you start multiplying these parts together like this, what will happen? We will left with only this expression. Here I dot I with this one, only this part will be left, AX BX, AY BY and AZ BZ. Since another product like this I dot j or j dot k, as they are mutually perpendicular, they will vanish. Therefore, the expression for A dot B for two vectors will be like this. Now, let us solve some numerical problem based upon this discussion. The very first question we have taken is that show that the vector A, this is vector A, which is equal to 3i cap minus 2j cap plus k cap. It is a three-dimensional vector. Another vector is vector B, that is I cap minus 3j cap plus 5k cap. And one more vector is there, that is what C vector. They form a right-angled triangle. They form a right-angled triangle. So, here we are given with three vectors, and what we have to prove is they are forming a right-angled triangle. First of all, if they are forming a right-angled triangle, then the angle in between any of the two vectors, that should be equal to 90 degree, means the dot product in between these two vectors, that should be equal to 0. Out of these three, we can have three possible dot product here, that is what A dot B, another one is B dot C, another one we can have is C dot A. So, out of these three dot products, any one have to be 0. And another condition for the formation of triangle is that the sum of any two vector, that should be equal to the third vector. So, here we can have a general observation that the A vector, that is equal to sum of B vector plus C vector. Here we are having A vector is equal to sum of vector B and vector C. Let us find out the sum. Vector B is this one, vector C is this one. When we will find out sum, then this component will be added to this component, means we will get 3i cap plus we will have here minus 3j, and here we are having plus j. It will be like minus 2j, then plus k cap will be there, and this is equivalent to A vector. This condition is satisfied, means they are definitely forming a triangle. But now, in order to prove that it is a right-angled triangle, we have to prove that dot product in between any two of these vectors have to be 0. Let us find out the dot product one by one. We are finding out first A dot B. A dot B, that is equal to AX BX plus AY BY plus AZ BZ. Here we are having a vector A, this one, and this is what AX, this is what AY, and AZ is 1 here. So, what about AX and BX? AX is 3, BX is 1 plus AY BY, it is minus 2, and BY is minus 3 plus AZ BZ, that is what 1 into 5. It will be like 3, then plus 6, then plus 5. So, it is not going to be equal to 0. Let us find another one, that is what B dot C. Let's find another one, that is what B dot C. What is happening here? Now it is the dot product will be like Bx Cx plus By Cy plus Bz Cz. And here this is Cx is 2, Cy is 1 and Cz is minus 4. Let's find out Bx Cx. It will be 1 into 2, that is 2, then plus By to Cy. By is minus 3 and Cy is 1. So what we are getting here is minus 3 into 1, then plus this is Bz and this is Cz, that is what 4 into minus 4. 5 into minus 4. It will be like 2, then minus 3, then plus 1. Then plus 1 will be there, then this will be definitely equal to 2 plus 1, that is 3, and 3 minus 3, that will be equal to 0. So it is proved here that the dot product in between B and C, that is equal to 0. It means they are perpendicular to each other. So both the condition of the formation of a right angled triangle are satisfied by these three vectors. Hence, definitely they are forming a right angled triangle. Now let's move to the next question. Here in this question, we are given with a particle which is moving from a point, three-dimensional, a point is given there in space, from this point to this point, under the influence of a certain force, three-dimensional force is given to you, and we have to calculate the work done. We know from the definition of work done that work done is equal to the dot product of force and displacement. So first of all, we need to find out this displacement vector. As the given particle is moving from this point to this point, I'm calling it final point and I'm calling it initial point. So displacement will be like S vector, that will be x2 minus x1. x2 minus x1, that means minus 2 minus 3 times I cap plus y2 minus y1, that is 3 plus 4 j cap will be there, then plus 5 plus 2 k cap. So this will be our displacement vector definitely. Let's have a better and simplified form of it. It is minus 5i plus 7j cap, then again plus 7k cap. So this is what displacement vector. And in case we have to, as we have to find out work done, then we need to substitute it in the above formula. The force vector is given to you. It is minus 2i cap plus 3j cap plus 4k cap, and the displacement vector we have obtained here is minus 5i cap plus 7j cap plus 7k cap. After calculating this dot product, we will have the value of the work done in this case. Let's move to the next question. Here in this question, we are given with two vectors, vector A and vector B, and we have to find out the scalar product of these two vectors. Simply what we have to find out is A dot B. That is what scalar product of these two vectors, and that will be ax bx plus ay by plus az bz. It will be like 3 into 1 plus minus 1 into minus 2, minus 1 into minus 2, then plus from here we will have 2, from here also 2, it is like 2 into 2. Means dot product is equals to 4 plus 3 plus 4, that will be equal to 11. Now in the next question, we have to find the angle in between these two given vector. We are having a vector A vector and vector B vector with us, and we have to find out the angle in between these two. From the basic definition of the dot product, we have the dot product A dot B in between these two vectors, that is equals to magnitude of A into magnitude of B and cosine of the angle in between these two. From here we will have theta or cos of theta, that will be equals to A dot B divided by A vector modulus or magnitude and B vector modulus or magnitude. Further we can solve it like A dot B, vector notation will be there. Here A dot B can be written like 2 into 6 plus 2 into minus 3 plus 3 into 2 divided by the modulus of vector A, that is 4 plus 4 plus 9 whole under root. It is ax square plus ay square plus az square whole under root. Here ax is 2, ay is 2 and az is 3. This is what modulus of vector A. Similarly, the modulus of vector B can be given as 6 square plus 3 square or minus 3 square plus 2 square. On solving this, we will have 12 minus 6 plus 6 divided by 4 plus 4, that is 8 plus 9, it is under root 17. And here we will have this is 36, this is 9, that is 45 plus 4, that is under root 49, that is what 7, which further implies is 12 upon 7 times under root 17. So this is what the value of cos of theta. And from here theta, that can have the value that is cos inverse of this value, that is this one. So this will be the answer to this problem. Thank you viewers. Thank you very much for watching this video. We will meet soon in the next module.